sample test. It says, draw a frequency distribution for these characteristics. Skewed right. That means there's a tail on the right that's a little higher on the right than on the left. And high variation means there's a lot of variance that's spread out a lot. And so high variation would be a low mound, and skewed right means there's more on this side than on this side. So maybe drop off like this. Okay, so that's number one. And then indicate where the median and mean would be. Well, the mode's the highest, most common value. And then the median is the middle number, and since there's a few more on this side of that high spot than on this spot, it would be over here. But the mean averages even those that are way out there into it, and it take those into account. So the mean would be the farthest over, and the median would be in between the mode and the mean. Now it says, would the mean and median be further apart with low variation? Low variation means kind of like that, which squeezes everything together so they would not be. Would not be further apart. Okay, that's one. Now, a highly paid executive for a major firm, so highly paid executive, that's important, firm wants to convince its investors that they pay high salaries. So he wants to make sure everybody thinks they pay everybody a lot. If the executive knows her statistics, then would she report the mean salaries or the median salaries for her company? So if there's a few high and then the rest of them, so there's the rest of them and then the few high ones, we got a skew like this, which means the median would be here and the mean would be further up. Kind of like what was in the first problem. So if she wants to convince people that they pay a lot, she would use the mean because it would be higher. Than the median. Okay, now I've rolled the dice. Well, I actually didn't. I did a computer program that did this for me, but rolled the dice 20 times and counted how many times I got a sum of 5. So I got 2 sums of 5s in the 20 rolls. Then I got 2, then I got 3, then I got 0, and here's all of them. So let's put these out in order here. So I got a 0, 1, 2, 3 ones, and then 2s. 1, 2, 3, 4, 5, 6 2s. And then 3s. I got 1, 2, 3s. And then 4s, there's none. And then I've got a 5, 1, 2 times. Make sure I got them all. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm missing some. 4. I rolled 16, so I'm missing 1. So let's count them again here. Ones. Zeros, 2, 1s, 3, 1, 2, 3, 4, 5, 6, 7 2s. 1, 2, 3, 4, 5, 6. One more 2. Okay. So what's the average mean? So I need to add them all up and divide by 16. So 10, 6, 16, 20, 33, I believe. Let's see, 10, 13, 16, 18, 22, 24, 26, 28, 30, 1, 2, 3. 33 divided by 16 is 2.0625. The mode is the most common, and that clearly is 2. And the median is the middle. Well, 16, it's going to be between two numbers. 1, 2, 3, 4, 5, 6, 7, 8 is half of them, so it's going to be between 2 and 2, which is 2. Okay, now it says find the range. Well, that would be 5 minus 0, which is 5. And then estimate the standard deviation. Using the rule of thumb, we could estimate. Now, if we have 16, it's 1 over the range divided by, if it's under 16, you divide it by the square root of n. If it's 16 up higher, you divide by 4. So we've got 5 divided by 4, which is 1.25. That's the rule of thumb estimate for the range. Then page 2. So now it says find the standard deviation. So we're going to need these numbers again. And since I've got them organized here, it's going to make this easier. So I got to take 0 minus the mean, which was 2.0625, and then I got to square it. I got to do that twice, and then I got to take 0 minus 2.0625. 1 is the next one, and square it, and I got to do that 3 times. Then I got to do 2 minus 2.0625 and square it, and I got to do that 1, 2, 3, 4, 5, 6, 7 times. And then I got to do 3 minus 2.0625, and I got to do that twice. And then 5 minus 2.0625, square it, and I'm going to do that also twice. So I got to get these numbers. So let's put the calculator on this side, and we're going to do parenthesis 0 minus 2.0625 close parenthesis squared times 2, and I get 8.5078. I'll carry 4 digits for now, and then I'll reduce that later. And then I got to do the same. Same thing, but with a 1. And there were 3 of those. So that comes out to be 3.3867. And then I've got to do with a 2. And there's 7 of those that have a 2 there. And that's 0.0273, and then I got to do it with 3, and there are 2 of those, and I get 1.07578, and finally with a 5. And I get 17.2578. Then I got to add these up. So let's see, 15, 18, 26, 34, 10, 16, 23, 37, carry the 3, 11, 12, 13, 23, 7, 10, 17, 19, 9, 10, 11, 12, 13, 30. So that's the sum of the squares, and the formula for the standard deviation is the square root of the sum of the squares divided by, since this is a sample, n minus 1. There was 16 times we did this, so 16 minus 1. So we got to take this total, 30.9374 divided by 15, and then take the square root of that answer. And I get the standard deviation to be 1.44, rounded off. Okay? So that's the standard deviation. And we can put those numbers in the calculator and check that, but we don't. Now it says give the Tukey 5-number summary. Well, that's when you do the median and the minimum and the maximum, and then the median of the lower half and the median of the upper half. So I'm going to put this back up here. So the median was 2, so that's Q2 is 2. Q3, Q4 is the max, which is 5. The upper quartile is, so since this doesn't fall on a value, it goes halfway between these, which is right there, so that's 2.5. Q1, Q0 is the minimum, which was a 0, and Q1 is halfway between here, and since it falls between, we use all 8 of these, and that falls between 1 and 1, which is 1. So there's a 5-number summary. Now if we draw a box plot, I got to go from 0 to 5, evenly spaced. And the middle median is at 2, upper quartile is at 2.5, and the lower quartile is at 1. So there's the inner quartile range. Goes from 1 to 2.5, which is 1.5, is the inner quartile range, the 2 middle quartiles. And then I draw a whisker out to my max, which would go to 5, but I want to find out if there's outliers here, and to the min. So I got to now find my fences. And the fences are the inner quartile range, which is 1.5, always times 1.5. It's always 1.5 of these. And that turns out to be 2.25. So the fence would be the upper quartile, 2.5, plus 2.25, which is 4.75 would be the upper fence, and 2.5 minus this 2.25, which is 0.25, is the lower fence. No, the lower quartile, Q1 minus 2.25. So that would be minus 1.25, which is down here. There's where the fences are. That tell you where anything beyond that is considered an outlier. Well, our lowest was 0, so we can draw this all the way down to our 0. The max is at 5, and since the fence is at 4.75, the max is beyond it, so the 5s are considered outliers. So finally, we drew the fences, and now we can say 5s are outliers because they are out beyond the upper fence. Okay. Number 12. What percentage of the data should be statistically between one standard deviation below the mean and the mean? Well, if it's a normal curve, and if we're looking at the mean and one standard deviation below the mean, in here, statistically, they're supposed to be 34%. So that's the answer to 12. 13, what percent is actually there? Well, the mean was, what was that? The mean was 2.0625. The standard deviation was 1.44. So if I subtract 1.44 from that, 2.0625 minus 1.44, I get 0.6225. Now, which of these data values are between, so they have to be bigger than 0.6, well, that would be 1 and up, and less than 2.06, so that'd be all the 1s and 2s. So there's 1, 2, 3, 4, 5, 6, 7, 9, 10 of them. Out of the 16, which is 62.5%. So 62.5% are in this one quartile below. 34 is what's statistically predicted to be there. Okay. If the 16 sets of dice are a random sample, what would be the predicted mean value of the population from these? So the predicted mean, predicting from the sample, you predict the mean that the sample had, which is the mean being 2.0625. That's your predicted mean. Okay? Now, the true mean is 2.22. Is it in the confidence interval? Okay, so now we have to figure out the confidence interval. So the margin of error is at the 95% level is, or the 5% level, is 2 times the standard deviation, which was 1.44, divided by the square root of the size of the sample, and the sample had 16. So we have 1.44 times 2 divided by the square root of 16 is 4, and we get 0.72. So we take the mean, 2.0625 plus 0.72, and we get the high value, 2.7825, and then we subtract it, and we get the low value, which is 1.3425, and we project that even though we thought that the mean was this is the mean of the population, that's our estimate of it, but we are pretty sure that it falls 95% sure, 19 out of 20 times the population mean will be in this interval. And so if 2.22 is really the true mean, it is definitely in there. So it's this sample supports, it doesn't prove, but it doesn't reject the idea that the true mean is 2.22. It supports it. So the true mean is in the confidence interval. Okay. Okay, now we got something. We're finally done with this dice rolling. We're going to go to this problem. It says the national average for the amount of sleep for an adult is 6.5 hours, plus or minus a little bit. So we're going to go with the average is 6.5. And CWU claims that their students sleep less, closer to 6 hours. To verify this, they do a poll. So, or a study, and they ask 100 students how long they sleep. So, state the alternative. Well, what's the null? The null is the normal. People sleep 6.5 hours on average, or at least somewhere in there, somewhere between 6.3 and 6.8, because it's plus or minus 3 hours, 0.3 hours. Okay, so then what's the alternative? Well, the college, CWU, is claiming that they sleep less. So CWU students sleep less than 6.5 hours. Specifically, they're thinking it's more like 6 hours. Now, let's see what they came up with. So they did a study and they got a mean of 5.9, and with a standard deviation of 0.45, the margin of error is 2 standard deviations divided by the square root of the size of the sample, and that was 100 students. So 2 times 0.045 is 0.9, and the square root of 100 is 10, so we have 0.9 divided by 10, which is 0.09. So we would have to add 0.09 and subtract 0.09 to get the confidence interval, where we think there's a 19 out of 20 times the true population will land in that interval. So so I take 5.9 minus 0.09, we get 5.81 up to 5.99. So it's predicting the amount of sleep CWU students is somewhere in here. The true value is somewhere in there. We're 95% sure it's somewhere in that interval, which is this 6.5 is not, and so that's enough information to reject the null. So the two possible results are you either reject the null because the data is significantly different, or you do not. And in this case, it is. So the response we have on this one is we reject the null. Now, that students sleep 6.5 hours. Now, if it wasn't in there, then you would say, well, we don't have enough information to do anything. That's the other possible result. Okay, now we have a percentage problem as opposed to a mean problem, and so the margin of error on a percentage problem is just 1 over the square root of n, and there was 2,500 selected. So that's 1 over 50, which is 0.02 or 2%. So that means determine the 95% confidence interval. So they said 47% favor stronger gun controls. And so we'd have to add 2 and subtract 2. So we'd go from 45% to 49%. Explain what this confidence interval means. So this means, we've got the confidence interval, that the true feeling about the Washingtonians is that they're somewhere in the range. The true amount that would favor stronger gun control is somewhere between 45 and 49. %, and 49% favor stronger gun control. And that is, we're 95% sure that it's somewhere between 45 and 49. We're not 100% sure, so there's still a chance that that could be incorrect. And finally, the last problem. So an IQ test has a mean of 100. So the center of all the IQ scores is 100. Standard deviation is 15. So if we go out 1, that's 115. Go down 1, it's 85 for the score. We're supposed to find a z-score, which means we have to get this to be 0. So we take any score they give us, like the one they gave us, 41, minus the 100. So now it's centered at 0. And then we want these standard deviations to be 1 wide, not 15 wide. So we divide by 15. So we get 41 divided by 15, which is 2.73. which means if we go down here to 2.73, that's somewhere between 2.7 and 2.8, so somewhere between 99.65 and 99.74, so it's probably about 99.7. 99.7% are that's the percentile, which means 99.7% of the people have lower IQ scores, and only 0.3% of the people have higher IQ scores. So this is one bright person according to their IQ score. Okay, that is that test.